Hello everyone, I am Aswani, Assistant Professor, Department of AIML at MLR Institute of Technology. Welcome back to another session of Artificial Intelligence. In this today's session, we are going to learn about Python libraries used for AI. Let's see the overview of this session. In this session, we are going to see various Python libraries such as TensorFlow, Keras, Pandas, NumPy. Okay, and to each and every library, we are going to see the example how we will import, how we will perform the methods by using those libraries. The first one, TensorFlow. The TensorFlow is a framework which is a open source and which is used to perform the mathematical operations. So it will apply in the program, and whatever complex mathematical performance is mathematical computations are there, it will perform all those mathematical computations without interacting with the user. Okay, let's see. TensorFlow is a very popular open source library for high performance numerical computation developed by Google. Okay, so the Google team is developed this TensorFlow library, and which is having the tensors. And if you take vector or scalar or any matrices, the basic formation is a fixed one. Whereas the TensorFlow is applicable to all those things, and it is applicable to the cubes also. Whereas scalars, vectors, matrices or cubes also it is applicable. Okay, as the name suggests, TensorFlow framework that involves defining and running computations involving tensors, the mathematical objects that can be used to describe physical properties. It can train and run deep neural networks that can be used to develop several AI applications such as face detection, handwriting detection. For doing all these things, we need AI. Either you can you want to image recognition, classification, or a handwriting detection. We need any AI model to do that model, to perform certain task by that model. We need a TensorFlow. So we need this library, and we by using this library we can make that AI model, and we can easily use that model to identify or recognize or handwritten anything. We can use that using this model we can perform the tasks. Okay, let's see the example. So here, importing TensorFlow. This TF is the alias name to the TensorFlow as TF. Initializing two constants using TensorFlow constant. It will be either array or list. Okay, we are defining two constants using TensorFlow. After that, multiplying these two constants using multiply method. So x1 into x2, x1 comma x2. So individually it will be multiplied each and every element. Later it will produce the result. That result is stored into the result variable. We are printing that result. So if you have written the same print result, then it will be displayed in the form of tensor, but we want in the form of array or list. So we are using NumPy method here. It will perform the multiply 1 into 5, 5, 2 into 6, 12, like that. After that, it will convert into the list or array. Then it will display the output. Let's see. This is the output of 5, 12, 21, 32, 3 sevens are 4 eights are, like that. It will print the array like this. So look at here. Multiply x1 comma x2. The multiply is the method which is available in the TensorFlow library. TF is the alias name for the TensorFlow. Without interacting with the user much to this program, just we are using multiply method, and we are passing the two constants which we want to multiply, and it will perform the computation internally, and it will produce the output in the form of tensors. We want to convert that into the array or list. That's why we are applying this method NumPy, and it will produce the output like this. Okay, Tensor is an open source framework, and which is used to perform the mathematical computations. Okay, any type of forms, either vector or scalar or matrices or cube, any type of forms, it will be applicable the TensorFlow library. The next library is Keras. It provides many inbuilt methods for grouping, combining, and filtering the data. So whatever pre-processing to do that data will use the Keras. Keras is used on the TensorFlow. Keras are used on the TensorFlow. Keras is a popular machine learning library for Python. It is a high-level neural network API capable of running top of TensorFlow. By using the TensorFlow, CNTK, and Thano, it will perform grouping, combining, and filtering the data. So whatever model you want to train, we required some data. The data is very important. In the data, if anything, if you want to grouping or combining, filtering, we need a Keras library. Okay. It can run seamlessly on both the CPU and GPU, and the TensorFlow also can run on the CPU and GPU efficiently. Keras makes it easy for machine learning beginners to build and design neural networks. So we'll give the input, later it will apply some library. After that, we will perform, will build a neural network. After that, output layer. So the operation of the from the input to the input and the library. After that, neural networks, building neural networks. After that, output layer. One of the best feature of Keras is that enables easy and fast prototyping. Okay, let's see the example. So here, Keras model import a sequential and dense, means the layers, adding to the layers. So sequential is the method it will perform, and adding the layers. Let's look at one. So 64 units, and here we are using a activation layer. Activation is the RELU, rectified unit layer. Next one is input dimensionality and dense units. So 10 activation here is softmax for add. So next, compiling the model. Will perform the loss, will know the what is the mean squared error loss, will try to reduce that loss unless it will be neutral. If it is neutral, that loss is, for example, if you reached 0.01 is the error or loss, whenever we are repeating the same process multiple times, we are reaching with this output, then it is that state is called as neutral state, and will stop repeating the procedure multiple times, because when you perform also we are getting the same. So that is the optimization stage. Next, print the summary, whatever we are applying, and we will get that summary of that model. Okay, so here input layer and activation layer. The dense layer is used to add the each layer to the model. Okay. Next library is Thano. Thano is a popular Python library. It is like a toolbox which will have all the algorithms or patterns, and it is applicable to applied on the CPU and GPU. Whereas if you apply in the GPU, it will work efficiently. So the library that is used to define, evaluate, optimize mathematical expressions involving multi-dimensional arrays in efficient manner. It is achieved by optimizing utilization of CPU and GPU. Both it will applicable to both. It is extensively used for unit testing and self-verification to detect and diagnose different types of errors, abnormalities. Thano is a very powerful library that has been used in large-scale computationally intensive scientific projects for a long time, but is simple, approachable enough to be used by individuals for their own projects. Thano is one of the important library which will perform the which is used to define, evaluate, and optimize mathematical expressions. Just if you give the 2x plus 1, then it will train the model that 2x plus 1 to identify this formula. We are not saying that it is a formula, it is itself, it will train that model to say that it is a formula, and it will learn that it will learn from the data. Okay, let's see the example. So import Thano, import tensor. It is also work on tensor, like ds scalar. So here we are giving the x, later x power 2. After that, whenever we are performing f of 4, By default it will goes and it will perform the operation, it will print the result. So square of 4 is applied and it will give 4 4 is 16, and again we are passing 10 as the value, then 100 is the value which will be displayed in the form of floating point representation, 16.0, 100.0. So we'll give the values and it will learn from that values and it will be evaluate the expressions. Later it will produce the output, that is the Tano library. The next one is PyTorch. This PyTorch is taken from the C as a torch and it is useful in the various scenarios. Let's see, PyTorch is a popular open source machine learning for Python based on Torch, which is an open source machine learning library that is implemented in C. It has an extensive choice of tools and libraries that support computer vision, natural language processing, and many more ML programs. It allows developers to perform computations on tensors with GPU acceleration. When we are using GPU, it will perform fast and efficiently, and also helps in creating computational graphs to represent visual basic. Then we will use the PyTorch and it is taken from the C and it is mainly focused on computer vision, natural language processing, deep learning, various algorithms, supervised, unsupervised, etc. Okay, let's see the example. We have taken Torch, we have imported Torch library. Next, this one is a neural network, and to optimize we will use the stochastic gradient descent, SGD. Next one is activation function, that is a basic one, ReLU, we will be used in this example. Next, defining the simple neural networks. After that, forward to perform the process. It is used to tell that to perform the process. Later on, here there is one input layer and one hidden layer, only 2 layers. In the input layer, one on hidden layer, there are 10 neurons. Next, creating the neural networks. Let's see here, torch.tensor, and here we are giving the values 1.0, 2.0, 3.0 like that. Later that, after performing activation, later we will find the mean squared error loss and optimization using the SGD, stochastic gradient descent, the general method to normalize the error. After knowing the mean squared error, again it will repeat the same procedure to neutral that error. Then train that network after performing. Here for each loop, the range is 1000. For each 100, it needs to be print the error. So after performing 100 iterations, it needs to print the error. After let's see, the first 100, second 100, third 100 like that. After 1000, after reaching the 1000, the error is minimized from 0.0573 to 0.0018. Later it will print the value 5.0. For 5.0, 11.0887 is the value. After reaching this, it will train the network. After that, print the result, making the prediction as a result. That is PyTorch library. Okay, the next one is scikit-learn. This one is one of the important library in Python. Scikit-learn is one of the most popular ML libraries for classical ML algorithms. So in this scikit-learn, which it contains the popular algorithms, no need to write a design. Just we will use that scikit random forest SVM. It will go and find the patterns by using that algorithms. Okay. So it is built on top of two basic Python libraries, NumPy and SciPy. This NumPy for the numerical and SciPy is the scientific research projects. Scikit-learn supports most of the supervised and unsupervised learning algorithms. Scikit-learn can also be used for data mining, data analysis, which makes it a great tool who is starting out with the ML. By using this, we can train the models easily. Let's see an example. So importing NumPy for numerical calculations, later models, training and testing. We'll train the model, later we'll test. For example, it is 100 features, then we'll take 80% as the training and 20% for the testing. Next, linear regression is the algorithm. Next one is to evaluate the performance of that model. The performance evaluators are the mean squared error and R2 score. Next, we are taking the dummy data. Let's see, random is the value, rand 100 comma 1. So between this range, it will generate the random numbers. Split data into the training and testing data. So 80 and 20. Okay, later create a linear regression model. Just we are calling the linear regression model instead of writing the logic about the linear regression model, because this scikit-learn contains all the algorithms that is having a supervised and unsupervised. Train that model giving the x values and y values as the training. After that, predicting by using the testing data, evaluating the model by knowing the mean squared error and R2 square. After that, printing the result like this. Okay. The next one is pandas, which is used to manipulate the data. Pandas is a popular Python library for data analysis. It is not directly related to machine learning, as we know that the data set must be prepared before training. Without data set, we can't train the model. Data set is very important. So in that data set, if is any duplicate data or noisy data or irrelevant data, by using pandas, we can eliminate all those things. In this case, pandas come handy as it was developed specifically for data extraction and preparation. It provides high-level data structures and a wide variety of tools for data analysis. It provides many inbuilt methods for grouping, combining, and filtering the data. Okay, let's see one example. So here just we are importing pandas and giving the data, and data frame is taking as the data, printing that data as the table. So it will print the country, Brazil, Russia, like this, countries, capital, area, and population. Okay, so in this session we have seen various Python libraries and with the examples like Tano, pandas. Okay, next scikit, PyTorch, TensorFlow. Okay, we have seen all these Python libraries and with the examples also. In the next session, we are going to see image classification using these Python libraries in CNN. Thank you.